The next element for this topic is hydrogen. We have already talked about water and its reactions, and we have realized that in a special way, water generates hydrogen when it reacts with metals. Interestingly, hydrogen can also generate water when it reacts with oxygen. The name hydrogen is derived from Greek words hydro and genon. Hydro means water, genon means generator. So hydrogen is a water generator. From our previous experiments, we have learned that water reacts with metals to form hydrogen gas and some metal hydroxides. Now, our main interest today is hydrogen. Our main interest in the previous class was water. Now, as you have seen, hydrogen is the simplest and lightest element on Earth. It does not occur freely, but it is usually found in combined form in compounds such as water, such as sugar. It is also found in methane gas that we use for cooking and as a laboratory gas. There are so many other compounds that we have not mentioned that also contain hydrogen. You will come to learn about them very soon. The laboratory preparation of hydrogen. Hydrogen can be prepared in the laboratory by the reaction of dilute acids with some metals. Just as we have already discussed in the previous section, some metals such as potassium, sodium, calcium, zinc react with dilute acids to form a salt and hydrogen gas. Now, dilute hydrochloric acid is delivered into the round bottom flask containing zinc, and a reaction begins to happen, forming zinc chloride solution and hydrogen gas, which is collected by over water method. Notice that we are collecting it over water, meaning the gas that is here is wet. The reaction that takes place in the round bottomed flask is shown as follows: zinc reacting with hydrochloric acid to form a salt and hydrogen gas. We have already discussed how to manufacture or produce hydrogen in the laboratory, and we collected it by over water method. But now that gas is wet. That means it may not be able to carry out experiments such as combustion because of the wetness or the water. And therefore sometimes we require our hydrogen to be dry. So in order to dry hydrogen, we'll use this setup in this diagram where moist hydrogen is passed through anhydrous calcium chloride. This is a drying agent that absorbs moisture from the gas, and then we collect it by this method known as upward delivery of the gas or downward displacement of air. collection of gas known as upward delivery is possible because hydrogen is lighter than air. We have just seen that we can collect hydrogen gas with two methods. One was over water method, and the second one was upward delivery or downward displacement of air. The property that allows us to collect hydrogen using this method is that it is lighter than air. All gases that are lighter than air can be able to be collected using upward delivery method. Over water method is also known as downward displacement of water. This is possible because hydrogen is slightly soluble in water, and therefore it can be able to displace water. The gases that are very soluble in water cannot be collected by over water method because they would dissolve in water. Next, downward delivery or upward displacement of air is another method of gas collection that we can use to collect gases that are denser or heavier than air. These gases will displace air from the gas jar outwards into the atmosphere, and it will be filled with the gas eventually. So the density of the gas is very important. Sometimes the gas may be having a very close density to air. For example, when you're collecting oxygen gas, in this case, we will use a syringe to collect the gas. It does not matter the density of the gas, but it can be collected using a syringe. Also, a syringe has the advantage of collecting a measured volume of gas. Some experiments would require you to measure the volume of gas produced as the reaction takes place. A syringe would be the best option.